Welcome to another community office hours for the CDK for Terraform. Today we have some special guests from the Mozilla Pocket team that are going to talk to us about how they use the CDK for Terraform in their workflows and in their infrastructure. But before we get into that and dive into the main topics, I do need to cover our community guidelines, which are to be welcoming, be inclusive, friendly, and patient at all times, be considerate, be respectful, and be professional. All these things should be obvious, but hey, it is the internet, so welcome. So if you've been to these office hours before, you may recognize some of us, but for those just joining us for the first time, we should probably, for good measure, make sure you know who all of us are. I'm Cole Morrison, a developer advocate at HashiCorp, and I'd like to pass the baton over to Sarah.
I am Sarah MacDonald, the product manager here at HashiCorp for the CDK for Terraform.
And so we're the HashiCorp folks you've likely seen, but we also have our guests here, Kelvin and Mathijs. Kelvin, would you like to introduce yourself?
Hi, I am Kelvin. I am a senior software engineer on the backend team at Pocket.
And then Mathijs, if you wouldn't mind.
Hey, I'm Mathijs. I'm also a software engineer at Pocket. I joined about 5 years ago. Glad to be here.
Nice. And just to get a little bit of background so we know who we're talking to, for either of you, how long have you been in the technology space, specifically within the infrastructure area, right? Because we've talked a lot about how the CDK, y'all have been using it to empower developers, which is an important part, but how long have both of you been in this specific space?
Kelvin, you want to start?
For me, I have been kind of in my career, I started off being full stack, and for the most part, I was heavy on the back end. So I have kind of been doing infrastructure for about 5 to 6 years now. But I got in heavy on just the back end after joining Pocket and a little bit of my last job.
Nice, nice.
And somewhat similar for me, I started at a small startup in Palo Alto about 6 years ago. Like I said, I joined Pocket about a year after that. So, and I've kind of moved from full stack to only really doing infrastructure about a year ago. So definitely much more of a like developer than a specialist in infrastructure.
Yeah, interesting. And I kind of had the same background as well. Aside from necessity and your position perhaps being what got you into it, did anything interest you and draw you into it that were like, okay, I do want to get into this space and try it beyond just a job thing? Or was it purely just, well, we need it and I got to get it done?
Well, it started off for me of like just being thrown into it because it kind of needed to be done because I started at a consulting agency. But then I kind of started really kind of liking how the pieces come together when you just have an application and how it's grown over the years. It used to be, you could just host like one file on like an FTP server and like kind of just have the IP to that. And then it kind of just started growing into like all these little pieces and components that come together to like make a very robust like web application. So that's kind of where I found the interest in infrastructure.
Nice. And Mathijs?
For me, it's very much the latter. It's a necessity. I love to focus on our product, on our users. Infrastructure for me is just a tool to make that happen. I almost feel bad saying that to CDKTF folks, but to me, it's just a tool, and the end result is really what matters to me.
Well, hey, it's good to get all the different perspectives. Before I go on a little bit further, Kelvin, can I get you to get just a hair closer to your microphone, just for the volume wise?
Sure.
So yeah, that's great. In terms of background, thank you for sharing the information. The next thing I kind of wanted to cover for the unacquainted is getting up to speed on what Pocket is. Obviously, it's been around for a while, but I'd love for Mathijs and or Kelvin for you to give us in a nutshell of what Pocket is.
I could start with that. Pocket started out as a save for later tool where you save things like articles, anything really on the internet. And you can consume them later, even offline on any device, any browser. It's been acquired by Mozilla, so we're now part of Mozilla. company, and we've started to focus much more on recommendations. So today the focus is very much on focusing on the broader group of people who don't want to scour the internet for content, but who want to see the best of the internet. So we have curators and machine learning folks, and we try to give people like a really nice slice of the internet for them to consume. Kelvin, anything you want to add to that?
No, I think you summed that up beautifully.
All right.
Yeah, I didn't realize that it had shifted more towards a recommendation engine, but I can see how bridging the gap between infrastructure and development would help with that, because I assume that the infrastructure pieces and services that you use aid in that service delivery. So speaking of which, since we just brought up some tech stuff, from an engineering perspective, what is the Pocket project? What does it consist of? What are the technologies that are used for it?
Well, it's actually a lot of things, and that also is relevant for why we use CDKTF. We have a lot of services. Like I mentioned, we started out with Save for Later, and now we've added like recommendation products on top of that. That all means that we have a wide variety of services, and that also means we're doing the same types of infrastructure many times. So that means we need to be really fast about deploying new types of infrastructure. And I hope that the demo that we're going to do today will help show like how we've been able to succeed with that.
Nice. And so obviously the CDK for Terraform wound up being one of those tools, and that is kind of our main topic today. And that's something I wanted to ask. Maybe I'd like to pass this over to Kelvin. What went behind the decision to choose the CDK for Terraform for the purposes that you're using it for?
So that has a history behind it. So Pocket, we've kind of tried everything that most companies or most engineers have probably tried in the past, of going from just clicking around in a console, for example, to like create services, and then move into, okay, we need a way to be able to replicate this. So going down the CloudFormation path, we went down the CloudFormation path. We saw that there's a lot of duplication, a lot of code to just like get certain services up, and a lot of like repetition across services to also get some basic things up, even things like just lowercase and something. So from that we discovered Terraform, and then we kind of loved it, but that was Terraform HCL. So with Terraform HCL, we kind of write our code in Terraform, and that was pretty nice for us, because then we could like very easily version our code. We have our Terraform state that is also versioned, and we can share it as well. But that also got to the point where once we started building more robust services, it got a bit more convoluted with all the code in there. We tried the modules in Terraform HCL, but that also kind of seemed a bit heavy-handed. But then when CDKTF came out, that was like a game changer for us, because then we started thinking we are mostly application developers. Like we are not, an SRE team. We don't, spend our day just writing code for infrastructure. So if we could write our infrastructure in code in the language that we already use, that was a game changer for us, because then we can empower ourselves to work faster and more efficiently, and then also to build services faster. So that was the game changer for us when we discovered CDK for TF.
Does that sound about on par with what you'd like to hear, Sarah, from a product perspective? Do you have any thoughts on that?
Yeah, I mean, it's so great to hear, because I think that is a lot of what we talk about with CDK for Terraform, is that it's not, depending on the team that you're on, it could be a great fit for you. Like I think Kelvin mentioned, if you are just writing infrastructure code all day long and you're on an SRE team, yeah, the HCL framework might be a perfect fit. But if you are primarily, an apps team and you have to context switch to kind of go into this other language, that's where we're hoping CDK for Terraform can come in and be a helpful tool. So yeah, really exciting to hear that.
Yeah, and so my question for you, Matthias, since the end result is what matters, what you guys switched to Terraform, but at some point a pain point came across. You're like, all right, let's go to the CDK for Terraform, right? Let's make that move. What do you remember? What that like last straw was? You're like, okay, we're gonna move over to this. And what did it take to make that jump over? Like, what was the transition process like?
Well, very much like Kelvin described, like CloudFormation was just so much duplicate code, and HCL was just so different from the languages that we worked with that it took us a long time just to make simple changes, and it was just like hard to read for us. I imagine that if you spend your days in HCL, that the opposite might be true, but we work with languages like Python and JavaScript, TypeScript. So those are the languages that we're really comfortable with. And which is really like, yeah, it like changes that should be simple, shouldn't require much code, and it should be like easy to make them.
Yeah, I've got a question in here in the chat from DevOps Rob, which is what was the learning curve like in adopting the CDK? Was it steep? Did you find it difficult, or were you able to just leverage what you know and move right into it?
I got involved a little bit afterwards. So for me, it was actually pretty fast because I got support from the rest of our team. But Kelvin, do you want to talk through like what our initial learning curve was?
So initially when we switched, kind of like what you said, Cole, we leveraged what we already knew from HCL and then leveraged that into CDKTF. The biggest thing that for us was currently there's a bit of a lack of documentation. So there is like the introduction documentation, but then after that, you're kind of on your own. But then with our knowledge from HCL, it was kind of a little easier for us to make that transition. The kind of transition that we're doing to is not essentially converting all our old services. We found it easiest with new services. I do understand that CDKTF is building out resources and CLI tools to help you convert your HCL into code. So we are kind of hoping that that becomes a reality soon, and then we can start doing some of those migrations as well. For transition, yeah, pretty much what I just described.
Nice. Yeah, I know I know that the convert command was launched recently so just converting back and forth. Well, not back and forth, but converting over to settle those purposes for you. So question I have for Matthias and Kelvin next is, from beyond the tech perspective, how did that transition affect the product Pocket itself? Has it resulted in like a faster release cycle? Did it result in other changes that maybe the end users saw? Like, I'm just curious around that experience.
I think it's both faster. Like, I think, again, that's something that our demo will hopefully show, that it can be pretty fast to spin up new services. But beyond that, I think it really empowers developers to be closely engaged with the infrastructure. So it's no longer a separate SRE person who's setting it up. Everyone's in control of their own infrastructure. And I think that brings better understanding of your services. Also removes blockers, and if anything happens, it makes it easier to debug your infrastructure.
Nice.
Yeah, and then to add to that a little bit, you asked about if users also get to experience this. Like, I think like from everything Matthias said, it kind of trickles down, right? If we have experiments that we want to run with users, we can spin up those services faster, get the feature in front of users also faster.
Nice. Speed. And Sarah, did you have any questions or commentary on what Matthias and Kelvin have just told us?
I mean, it's great to hear definitely about their journey. I think it was interesting that Kelvin brought up the docs gap. That's something we're definitely actively working on this release cycle, actually. It's sort of building out those docs and migrating them over to the Terraform IO docs page where people can filter more easily and discover content. Because I do think that early, like you're saying, early adoption point right now, you have to dig a little bit. So we're hoping to improve that so that folks can onboard more easily. Yeah, but other than that, it's just really exciting to see the improvements to the speed, and I'm kind of anxious to get to the demo because I think the audience will actually be able to see that live, just sort of how quickly you're able to spin up a new service with what you've got going.
Great. Yeah. So speaking of live demo, that is the main meat and potatoes of what we're going to be doing today. It's also going to serve as an opportunity for Matthias and Kelvin to touch on best practices and architecture within the CDK for Terraform. So let me see here. It looks like before we go on, we do have one more question that I would like to field before we get into the demo. And that is, did the wider development team buy into the CDK pretty quickly, or was there a process to get them into buying into the idea of adopting it?
Since we're kind of using it mostly for newer services, it was pretty easy to kind of make that transition. And then also it was pretty easy for our team and other engineering teams at Pocket to kind of adopt it because of basically all the advantages and benefits that we've outlined before, which is we don't have a typical SRE team. These people just want to focus, we have folks that just want to focus on building the product and building the application. So anything that gets us spending less time building our infrastructure and being in control of it, being able to make simple changes was something that everyone was kind of pretty much on board with. So it didn't take a lot to transition. I imagine that might be different for a team with a dedicated SRE and trying to, convince their SRE teams like switch to CDKTF. Because like we said before, if that's what you do 24/7, that's not going to be that much of a problem for you writing some HCL code all day.
Nice, great answer. Thank you for answering. Thank you for the question, Rob. Okay, so it looks like it is that time to jump into the demo. So Kelvin, when you're ready.
Yeah, so while Kelvin is sharing a screen, I can maybe set up the demo a little bit. So
that would be great.
We'll be deploying a Hello World Apache Docker image in a environment that's like ready for production. And we'll do all of that with less than 150 lines of very readable code. And so what it means to be like production ready is that we'll have Pocket's best practices set up, meaning we'll have a dashboard that we can use to monitor our service. We'll have alarms set up. We'll have those alarms integrated with PagerDuty so that we can get alerted when those alarms are triggered. We'll have a load balancer to make sure the load is distributed equally across our tasks. We'll actually be using ECS here to run the Docker image, which is Amazon's managed Docker service. And hopefully the demo will show that the code that we do write is very much focused on this service, and it's just limited to like just the code that's really necessary to set this up. No boilerplate or very little boilerplate code that is kind of hidden in the package that we'll use. So with that, Kelvin, you want to start sharing your screen and we'll walk through the whole process.
Oh, I'm going to try to share my screen here. Give me a thumbs up if you see.
Yeah.
Awesome. All right, so what we have here is the base of a project and what we're going to be working with today. I kind of just want to give a brief overview of what we have in here in this directory. This is the typical directory that you would see within most repositories, or most of our newer repositories at Pocket. We define this in a directory as the infrastructure code directory, and then this is very typical of what you see there. The source directory is where we keep basically most of our CDKTF specific code. For the purpose of this demo, we are just going to use the main.ts, but in a more robust application, if we have more resources to create, we separate these into different files just to kind of make it a bit more digestible for our developers. We always have our lint test in here, which is ESLint, and Prettier, which is really important to us at Pocket to have some kind of standard across our code bases. We also have NVMRC, which we defined a node version in here if you're familiar with NVMRC. So developers that get into this code base can just run NVMUs and then be on the right node version as well. Then we have our CDKTF. This is a file that is specific to CDKTF. It defines the language, which we use TypeScript at Pocket to write our infrastructure. And then it also defines like a script that is run when we synthesize our code, which is essentially compiling our TypeScript code into JavaScript, and then also running that script to synthesize all this code that we write in TypeScript into something that is more Terraform friendly for you to be able to do your applies and plans on. The rest of it is just a package.json because this is the load script, and then also a tsconfig.json, which tells us where we are actually outputting our JavaScript code. And if you're familiar with TypeScript, excluding some files and including some files as well. So with that, we can go ahead.
Just want to call out, if you wanted to see these demo files, they're in the description below this YouTube video.
With that, I'm going to go into our demo. We're going to start out with an empty main.ts file. And what we want to do here, if you're familiar with HCL, is to create a stack. To create a stack in TypeScript with CDKTF, we start by creating a class. So we can create a class called HashiCorp Pocket CDKTF. This class needs to extend the Terraform stack from CDKTF. Which is the library that we use for CDKTF, obviously. And then this class, every stack accepts a scope, which should be a construct, which serves as your root construct for this stack because it's kind of like a hierarchy. So that would be a construct. And then a name for your stack, which is sort of used as a namespace when you build the application. And being TypeScript, you're being type safe and type in everything. Since this is an inherited, this is an inheritance and we're extending a parent class, we want to pass the same scope and the same name to the parent class. At Pocket, we build, go ahead.
Kelvin, could you increase the font size on your thing just a little bit?
I can do that.
Awesome, thank you.
Let's go to editor, generate the font size, and let's make this a bit bigger. How does this look?
Better.
Awesome. So at Pocket, we build services primarily on AWS. So if you're also familiar with HCL, we need an AWS provider. In CDKTF, we can pull in an AWS provider, pass it the construct. Now, since it's a hierarchy, we want to pass it this custom construct as the scope. We want to give it a name, which would be something like AWS provider. And we want to pass it some configuration. Typically, we start building our services in the US East region. So we're going to define that here as well. US East 1 region. Now, on top of this, we build, we use Terraform Cloud to manage our state. So we can have some state versioning and also for collaboration as well. So we're going to build a remote backend. And we're going to pass it again, the same construct. And then we're going to define the properties of our remote backend. To start with, we need our host name, which is where the backend actually is, the remote is, and that would be app.terraform.io. We also need our organization within our Terraform cloud, which is obviously Pocket. And then we would need our workspaces. Now, the workspace, we have one already defined, and what we want to do here is give it a prefix and call it HashiCorp Pocket CDKTF.
So just to clarify, this is a workspace that we set up before this demo. And also to reiterate that Terraform Cloud is pretty powerful, but really the only feature that we use is to store our state. And it was just very easy for us to use. It's just a secure way to store our state there.
Thanks, Mathijs. So with this and setting up our provider and our backend, we currently have the base of what we need to start building some resources. But ultimately, this is a script, and we want to be able to run it. So we are going to have to new up our stack. But to new up any stack, we need to give it a root construct for it to start from. CDKTF comes with a root construct, which is called an app. So what we want to do is new up a new app from the CDKTF, pass that as our root construct, and then give our stack a name. So I'm just going to call this Pocket CDKTF. Now, once we have this, again, ultimately, we want to be able to run this script and then turn all of this code, because this is not what Terraform understands, turn all of this code into something that Terraform likes and understands. What this becomes is a JSON that is very Terraform friendly, and you can still run your plan and apply on. To do that, we need to then synth this file. And this basically becomes a script that takes this class, runs it, and produces some Terraform friendly files that we want. So now that we have our base, we can go on to create some resources. To create resources, as we are in a class, we're going to start with creating our application. Now, to create our application, we are not going to be using the typical constructs that come with CDK. To show here, we're going to be pulling in our custom Terraform modules library, where we've created a bunch of libraries and constructs, custom constructs to build robust services in AWS. To kind of save us a little bit of time and repetition in our code bases. So we kind of dry up our code and then put that in this module and in this library, and then we pull it into our projects to use to create resources. As Mathijs
I just reiterate that because I think that's really a key part here. So we have this separate repo that's also linked to in the description, where we encode all our infrastructure patterns. And that's where we put like all the boilerplate code that we don't want to repeat across services. And so we're using that package in this demo to just spin up a new service with very little code. So the library is very opinionated. It's very Pocket specific. Those are the ways that we spin up our infrastructure. For example, to use ECS to host our Docker image. So basically, we encode all the duplicated codes in just like that one package, and we just pull it in. And it has a lot of advantages, as we'll talk about throughout this demo.
Thank you, Mathijs. So being in the class, we are going to start building some resources, and we kind of want to keep our code clean. So we're going to create a private function here, which basically we're going to call create application. And to create our application, we're going to new up a new Pocket ALB application, which is one of the modules that we've created. This will help us create most of the services that Mathijs talked about earlier, but we're going to go through this step by step and then talk through some of the configurations that we have here. So similarly, we are going to pass it the construct, which is our stack, and then we are going to just name this. We can just call this application for now. And then we are going to now define some configurations for this application. And to be good citizens, we are going to just call this function in our constructor, because when we new this stack up, the constructor will be run, and then we can run the rest of this code with the stuff that we are creating here. So to start with, we're going to start with some basic forms of our configuration. We have our internal config. Now, this essentially tells this module to define this service as a service that would be available publicly on the internet or internally within like a private network, like a VPC. So for the purpose of this demo, obviously we want to see it online. So we're going to say that we don't want this to be internal. We're going to define a prefix. What a prefix helps us do is it helps every resource that is created by this module to be created with this specific prefix. So it's easy for us to identify what service resources belong to when we are just, clicking around in a console or looking for things. Now, to help us fill in this a little bit more easy, I am going to copy some predefined configurations and names and just place it up here. Typically, we put this in a different file and then we import it in, kind of talking to how we separate files in the beginning, but we're going to just have this here. This configuration just has the prefix, which is a combination of the name and the environment. We have a short name, which I'll talk about very soon. We define a domain, and then we define our tags. So for our prefix, since we already have that in our configuration, we're going to bring in our prefix. We're going to define next our ALB prefix. Now, this is explicitly named ALB 6-character prefix because we found this out by deploying. So when the stack is built, the name of the AWS ALB that is generated in the end appends things like a date and I think a time to the end of the name. So all you have is the prefix, and AWS limits this to a certain number of characters. And we found that when you keep it at 6 characters or less, you actually have enough room to create your ALB. So we explicitly define short names for every service that we create. So that would be the short name that we have here. Next, we are going to define our tags. Mathijs, you want to talk to how tags are important on Pocket?
Yeah, so we have some standards around putting tags on our infrastructure that help us with cost analysis and with just finding our services in general in AWS. So I think there are 2 tags that we assign there. If you want to scroll up a little bit, we define what environment the service is in, what the environment the resource is in. So that could be a dev or production. In this case, we've just hard-coded that to dev just for demo purposes because we'll be deploying in our dev environment. And additionally, we tag it with our service name. So it's just really easy to see, like, if we want to aggregate the cost by service, to do that using those tags.
Thank you. So next, we're going to define another configuration, which is optional, but that is our CDN configuration. And as the name implies, this would spin up a CloudFront distribution if we set this to true, if it's a public service, and then false would basically just not build a distribution, and that doesn't matter if it's public or internal. So for the purpose of this, we're going to set that to false. Then we're going
Can I just jump in here to say that I really love how easy this interface is so far. You just set internal to false to mean that this is a private service. And if we had set, sorry, that this is a public service, and if you wanted it to be private, you could just set it to true. So we've really like customized this interface to be as developer friendly and specific to the only the things that Pocket needs to configure for services. So I just love that we have a CDN flag that you can just flip to true if you wanted to add a CDN in front of this.
I really like how this interface looks as well. The next thing that we have here is our domain. Obviously, this will define what domain that this public service should be on, so that we can build out our domain and then also provide SSL certificate for our service, because security is important as well. Now, this kind of ends some of the basic configurations that we do define, but ultimately we do want to deploy this Apache's web server on this. So we need to define an image and configurations for our container. So what we do have would be our container configurations, which is also a property on this module. So with our container configurations, you can define, if you're familiar with ECS, any number of containers. So this accepts an array and accepts an object that defines the name of your container. For this, we're just going to call it an app. It defines your container image. And for this purpose, we are using Apache's HTTPD image. And then we also define our port mappings. This tells it what the host port is, and also what the container port is, basically what port is open on the container. If you're familiar with something like Docker Compose, it's a similar thing in ETS as well. So now that we've defined,
looks like you got host port twice there.
Oh yeah, container port. So this defines our container port and this defines our host port. All the red that you see here is also our IDE doing its job and linted and telling us that, hey, you're still missing some key properties on here, which is also something that we like. So use a good IDE, folks.
Yeah, I think, can I just say that in this case, that might not, the IDE might not be doing the best job that it could here, but I do think it's really powerful that we've defined this interface and that you can just the IDE should be able to tell you exactly if you're missing something or if you add something. And that might be a lot harder with HCL if you want to. I'm not entirely sure, but we are leveraging all the things we get with TypeScript and Node by using a well-established language with good IDE integration. Yeah.
It's pretty decent when you use TypeScript and have clear interfaces and types defined. It kind of helps you be a little more type safe, and your code is comes out a bit less buggy than it would otherwise. Next, we're going to define our exposed container. This is a setting that essentially tells our load balancer what the target is from this ECS, the target container that is running on here, what port it should actually expose and actually hit our target with, and then the health check, typically to basically just make sure the service is up before it puts any tasks from the service into rotation. Next, what we're going to define would be our ECS IAM config. Now, this is a setting that if you're familiar with building anything on AWS, you might already be familiar with. But essentially, we define a prefix to create every policy or role that we create with this service, any IAM policy or role that we create for this service. And then also we get into now creating the actual policies. Now, task execution role policy statements, which won't be really defined, but a typical use case for us for this would be at Pocket, we try to keep our secrets outside of our Git repos, and also outside of, we try to keep it outside of our Terraform state as well. So typically for a service, we would pull in secrets from secrets manager to use as environment variables. Some of these could be just like a Sentry DSN, so we can report errors to Sentry. So to do that, ECS, when creating a task, needs to have permissions to actually access that secret in AWS. So we define task role execution statements, which create a policy that allows ECS to do that when creating the resource. We also define task role policy statements. This becomes the policy statement for the role that actually is used by the task when they are running, essentially. So if a task is running and needs to store images on S3, on a private bucket on S3, it needs permissions to do that. We need to define those policies that allows that task to be able to access S3 and then put files or images on there. We also make room for adding predefined AWS managed policies, because typically when you're trying to just create a task, what you're trying to do might be already handled. All the policies that you might be trying to assign might already be handled by a managed role in AWS. So we make provision for just adding an AWS managed role as well. Mathijs,
so just to reiterate, like the execution role is when the task is being started, and the role policy, that's when the task is like running in production. I always mix those two up, to be honest.
Yeah,
right?
We probably need to define those clearer, but.
And the nice thing about using like your own package is that we do have the freedom to rename those if we wanted to. Like we could theoretically use a different name in the interface we expose to our services from our shared library.
Yeah, and that's really important too, because like that's the cool thing about CDK. You can build on top of it and then build pretty much anything custom to satisfy your specific needs and make it very easy for your team to actually use and be more efficient. Next, we're going to define our auto-scaling policy. Now, our auto-scaling configurations have, at minimum, we have to define a target minimum capacity, which for this purpose, you're going to step to 1, and our target maximum capacity. I'm going to invite Mathijs to talk a little bit about why auto-scaling is important to us at Pocket.
Yeah, like obviously you don't want to plan capacity, so auto-scaling is always key. This is just a really nice way to control that. Really simple for developers. Just say how many tasks you want. These are like, we have additional parameters that allow you to control how quickly services scale up when, like Kelvin is just showing now, when a threshold is breached. At Pocket, we scale on the CPU loads. We've also had like discussions about trying to scale differently, but that's currently what we do. So if CPU breaches certain thresholds, we add additional tasks.
And this is also, we can be able to handle, the varying loads at Pocket based on the service. We handle from anywhere from tens of thousands to hundreds of thousands, depending on which service. So we need to be able to either scale quickly, and also for cost purposes, we need to be able to scale back when we're actually not using all those resources.
Yeah, if you open up a new tab in Firefox, you'll actually see content from Pocket there. So we actually have to serve a very large number of users in that way.
So the next thing we're going to move on to here is alarms. Another key thing for us at Pocket. Mathijs mentioned this a little bit earlier. We need monitoring, of course, but when things don't go as we expect, we also need to know about it. We need to be alerted so we can take action when things go wrong. At Pocket, we really care about HTTP 5xx error percentage, which is essentially what fraction of requests are failing with a 500 error. That's a key metric for us, and that's something that we want to react to and also be more proactive about. So we set thresholds that conform to our SLAs internally. So when services breach these, we can respond and react to them. The configuration that we have here, it allows you to either leave it and not set it at all, which means that it's going to define reasonable defaults for Pocket, or you have the option to just set your thresholds. So this could be a threshold of, say, okay, 10% of requests are failing. Use maybe 2 evaluation periods. This is all if you're very familiar with CloudWatch as well. And then a period that this should be evaluated on. So we say, okay, 10 minutes for 600 seconds, because this is all defined in seconds. And then also actions, because what's an alarm that does not actually tell you what's going on, right? Because then you wouldn't really know what's going on. You would just have alarms that are going off in CloudWatch. So if you don't check your dashboard, then things are just happening and nothing happens. We'll come back to our actions a bit later on, but I want to talk about our latency alarm as well. Because of the way we build services at Pocket and some of our services that integrate more to form like one federated service API for our clients, we need to, most of our services have to, uphold a certain like SLA and response time, which makes it easier for us to combine all those services and then federate it in a fast way to be able to serve our users. So we define a latency alarm as well that we monitor. So these are the 2 key alarms at Pocket. Similar to the above, you can also set your thresholds, your evaluation periods. So this is all in seconds. So if I want to define, say, 500 milliseconds, that will be 0.5. And then we also define our actions as well, because again, we want to know about what happens when these breach these thresholds, so we can take actions as well.
So just to reiterate, like these alarms are like very easy to set up with just a little bit of configuration, because our package, our shared library, like has these conventions built in. So I think this is like fairly readable code when it comes to setting up alarms. If you want to set them up in like something like CloudFormation, it would be many more lines, right?
Yeah, it would take almost as many lines to set up just one alarm in CloudFormation or Terraform HCL than writing something custom that you can reuse across your code bases. The last thing here, which kind of completes our basic setup, is code deploy. So Pocket, we are big on automation, and then we're also big on, so with that, we are big on knowing that our service actually is being deployed and actually it's not failing, so we don't rotate it into production for our users to hit bad services. So this is a required option for our module, which is what works for Pocket, that you define how you want to deploy the service. More typically, we would define this using code deploy, to use code deploy to deploy, but for the purpose of this demo, since we are now building out our full CI/CD, which we'll talk about a little later, we are going to just make this false and say that we are not deploying with code deploy here. And now all the red is gone, so it means that we did something right. So we can take a little breather here and maybe do a little recap of what we've done here. We've set up our basic domains, ALB. We've made configurations for our image. We've made configurations to tell our ALB where our image and our ECS service is actually at. We've defined some roles. Well, more explicitly, we've used that AWS managed role to define how to create these tags. And we've defined our auto-scaling policy, and we've defined some alarms. Then also telling it that how we're going to deploy this, that we're not going to use code deploy.
Amazing.
Oh, how is it looking so far?
It looks great. I'm thinking back to my times when I've defined an ECS-based infrastructure in CloudFormation, because you talked about the CloudFormation alarms. That made me chuckle, because there's a lot more code there, and there's a lot more curly braces and a lot more a lot more stuff going on. I did have a quick question for you. When coming up with this interface into your all's modules, how did you determine what things you needed to include? So for example, you have alarms in there, you have container definitions in there. Was coming up with those specific properties you wanted defined here an iterative thing, or was it something you all agreed upon up front before making the module that allows you to do this?
It's very much an iterative thing. basically we ask ourselves, is what we're configuring specific to one service, or is it something that Pocket services share? If Pocket services all need to have the same like thresholds for alarms, we can just move that into as like a default into our shared package. It's also, what makes the iterative aspect really nice is that we're using these node packages. So upgrading to a new package is really easy. We can lock in service to a certain package, and if and when we need to make use of a new feature that's in our shared package, we can just upgrade that service independently of the rest. So it's really easy to do version management because we're just using like an existing ecosystem in Node.
Nice. Did you have any questions, Sarah?
Well, I had one sort of more big picture question, I guess. It's been really fun just to watch, half an hour and 100 lines, and you've really gotten most of the way there with being able to kind of deploy this web service. And I guess what I'm curious to know is how would this have looked in your workflow prior to adopting CDK for Terraform? So if you're trying to kind of accomplish the same task, what would it have looked like in your earlier workflow, if that makes sense?
Yeah, that would have looked very different and involved a lot more files. Because if you're familiar with, like Cole said, spinning up an ECS service, that involves creating a cluster, creating a service, defining your container definitions, which is a pretty decent JSON that you have to define, defining your image, defining your application load balancer, building target groups, building security groups to actually allow access to your service. So it's a whole lot of things that take up a lot of room and requires a lot of files to create. This is basically less than a fraction of what you would have to do to create a service like that.
Sure.
Maybe this is also a good time to point out that like we can actually test our infrastructure in this shared package. So we have really good test coverage. Kelvin, can you remind me how those tests are called?
Snapshot testing.
All right, we use snapshot testing. So we take a snapshot of how the output of JSON should look like, and then we can assert that it meets like the expectation when we make changes there, which is something that we could never do with like our, at least not with CloudFormation. So when you asked like, what did it look like previously? It meant like a whole bunch of iteration of deploying something to production and then seeing what was wrong and then going back to development. And the cycle is just so much longer because of that.
Mm-hmm.
Awesome, thank you.
Cool. I'm going to move on to, as I mentioned before, we're going to come back to our actions for our alarms. We use PagerDuty at Pocket. I'm going to kind of put a snippet in here since we're using classes. I'm going to create a class for PagerDuty and kind of talk through this a little bit and then have Mathijs kind of explain how we think about alarms and alerting at Pocket. At Pocket, we have an incident management service, which we also build on Terraform and then keep its remote state also in Terraform. What the service does is that it also outputs PagerDuty escalation policies, IDs, which we then fetch with our custom Pocket PagerDuty construct. We kind of take the outputs of the escalation policy IDs. We use that to create SNS topics in AWS that we integrate with PagerDuty using those policy IDs. So when we have that, what we get from this construct back is just SNS topics that are for either our critical alerting or for our non-critical alerting. So now that we have this function, we can actually pull in those topics in our function and say, okay, so we have our pager, and this would be the pager that we have down there. What we get from this, obviously, is a PagerDuty. If we're going to type this, we get a PagerDuty, Pocket PagerDuty class. And that class contains the SNS topics for either critical or non-critical. Now, before I define an action here, I also want to talk about how easy it is if you're using, a language that you're familiar with to also do certain things like conditionals. So in here, I'm going to say, okay, so if this environment is dev, which is what we are building here, then I don't want to define any alarms because I don't want to ping anyone if services go wrong on dev. But then I want to create an SNS topic for when we are on production, and then grab that ARN of the SNS topic to define that here. So what is
Can I
basically
just,
say? Go ahead.
oh, sorry. Can I just emphasize that like, it's really nice that we're able to do this code in TypeScript. Like I wouldn't know how to do this in HCL. I'm sure it's possible and other people might know how to, but because we're working in a language that our developers are already familiar with, this was just a really easy change to make. Yeah. You mentioned something about like how we do alarms. So at Pocket we use PagerDuty. I think it's like universally true that nobody likes being on call. Nobody likes to be called on their phone, but at least like the integration, at least PagerDuty works really well, that if you're called, it's always really clear like what's going on. And at least they're really easy to set up in this way.
Yeah. Thanks for that, Mathijs. So now that we've added our PagerDuty integration and pulled our SNS, we have to remember to pull in the PagerDuty provider, because we always need a provider for services that we are using with our stack. Similar to the above, we need to give it a construct, we need to give it a name, and we also need to define a token. But again, we keep secrets out of our code base and outside of the state. So we're going to leave this as undefined. This is required. So we kind of have to tell it that it's undefined and then use an environment variable during CI to actually populate this when we are code deploying. So with that, and in 140 lines, we have our stack, and now we have to see if it works. So with that, I'm going to pull up a terminal here. I'm already kind of logged into one of our accounts. So I'm in the dev account. So what we actually want to do here is run a command. Actually, let me show that because that might be important. We're going to run a CDK synth command. What we have here is just a build. Typically, we have a production and a development environment. So when we are building, we have like maybe like a script that's called like build dev, which essentially would set the node environment to development. So we build all our resources with the dev So all we have here is just a build, which is setting that, which is something that we're just showing, but ultimately we're just trying to run a CDK synth, which will then run this command, build everything, and then synthesize our code for us. So I'm going to run npm run build here. This should synthesize our code and create a Terraform friendly JSON for us to be able to run our typical Terraform commands on as you would in HCL, which is your Terraform init, Terraform plan, Terraform applies, destroys, and what have you.
Can I ask if you ever look at that JSON?
Typically, no, until something goes wrong. But something barely goes wrong because a lot of people might look at this as like, like an abstraction on top of like Terraform friendly JSON. But what it really is like if you're using CDK, it's like your first point of entry into the Terraform itself. Like you're kind of trusting the CDK to generate that JSON for you. So you're not overly concerned about the output if your input is correct. So it kind of gives you that kind of safety and kind of a bit of a safety net that, okay, if I write my code well, which is in a language that you already understand, you're kind of doing the right thing. And if something goes wrong, you kind of know that it's not your fault in a way. So now that we have that CDK, but to your point, I think I'll just open it. So, folks just have a look here. It kind of builds this kind of JSON out, which is your stack name, your backend is remote. It defines all the resources that are in here as well.
So glad we don't have to write this ourselves, at least.
Yeah, no, I'm glad we don't have to do that. So that's what we have. To run your Terraform CLI commands on this, you essentially have to go into that directory. find a stack, go into your stack, and the stack name is defined by what we have here in the main.cs, which is what we named our stack as. So we are in our stack directory now. What we have in here is our CDK.tf.json file, and then we can run our Terraform init on that. Since we're using a remote backend, we have a remote backend with a backup and a dev in there because you have to be prepared because the demo goals are not nice all the time. So we select dev. That initializes our backend and pulls in all the providers that we need, and then we can run a Terraform plan to see what resources are going to be built here.
And maybe just to add here that we do this Terraform plan automatically in every PR triggered by GitHub to confirm that the Terraform is valid, and we can't even merge in if that fails.
Yep. And then we can go ahead and run our Terraform apply. This is going to also output the plan, but then ask you for confirmation if you really want to deploy this, which at this point we really do. So I'm going to hit a yes. And I'm sure you can see here that we have 41 resources to add, but those are just from those few lines of code, less than 150 lines of code. But then what we are essentially creating is all these resources that work together to provision a production-ready service that scales on its own, scales down on its own, has alarms, has dashboards, and all of those nice things.
So we're doing quite a bit, but there are a couple of things we aren't doing just for the purposes of this demo. So we're now running Terraform apply manually. Obviously, that's not how we do things in production. We use continuous deployment to automatically make changes to our infrastructure when we merge pull requests into our main branch. And for that, we use code pipeline. We actually also use Circle CI, which we've been using at Pocket for many years to build our Docker images. So for this demo purpose, we're just using a Hello World image from Apache. But obviously, like most of our services have custom Docker images with our application code, and those get built in Circle CI. We could, in theory, move that to code pipeline as well, and that's something we might do in the future. But currently, we use Circle CI for the build process, and then code pipeline and code build to build infrastructure, and then code deploy to actually deploy the service using a blue-green deployment. And thanks to Kelvin for setting up much of that to continuous deployments.
No, that wasn't just me. It was a team effort. Mathijs is just being kind. But yeah, that has really kind of streamlined our processes. We kind of had some issues with race conditions between deployments when we're using just code deploy, but then we switched to code pipeline so we can kind of queue the deployments and also supersede deployments that are already in place if they are basically kind of like following the same history on Git and are like deleted the head commit. So that has been really nice. So we don't have to keep running into that situation. It also helps us so we avoid a weird problem that we have when you initially deploy a service, because we are building some things on Circle CI and some things in code build. Sometimes you run into the issue where the resource that the Circle CI is trying to push an image to, like an ECR, is not available yet. So that can sometimes cause some issues. So we kind of were able to get rid of that as well, since we're deploying to like a more step-by-step kind of deployment using code pipeline. And while this is going, I think we should be done soon here.
Yeah, I have a quick question for Mathijs and Kelvin so speaking on the CI/CD front and speaking back to leveraging development tools, are there any tools from the TypeScript/JavaScript ecosystem that you've brought into the CI/CD pipeline that you wouldn't be able to use if this wasn't written in this?
That's a good question. Go ahead, Mathijs.
I was gonna bring it to you because I don't know what the answer is there. I do know that I'm relatively new to TypeScript and Node, but I liked the ecosystem. I'm coming from a Python background, which I think also has a really nice ecosystem, but it was pretty seamless to make that transition. So yeah, it's been a good experience overall.
We haven't really used anything, but I imagine, if things like we wanted to, make something a slug, like it would be easy to have a node and have an NPM. We could easily pull in packages that help us do simple things like that, which otherwise we wouldn't be able to do in HCL. And I believe in our Terraform modules repository, we actually pull in packages like that to make some things easier to do, which we wouldn't be able to do otherwise in HCL.
Nice. So filling in the gaps with existing NPM packages out there.
Exactly.
Nice.
I see that this is deployed here. So what I'm going to do is I'm going to grab a browser tab and also plug for Pocket. This is all provided by Pocket. If you open a new Firefox tab, all these recommendations, they are really good reads. You should go see them. But
it's
now,
addicting during work.
Now we're going to go to our domain and see if anything that we did here actually did anything. Moment of truth. And it works. So with less than 150 lines, we've deployed a service that is scalable. Like I mentioned before, I'm going to take this away. And then what I'm going to do is I'm going to also show some of these resources up in our AWS account as well. So what we did was we created an ECS, right? Here it is. We have our ECS cluster. We have our ECS service, all with a prefix that we defined. We have our tasks, and we have them running as well, which is our HTTP image that we try to deploy right now. What we also have is our application load balancer. Which has also been defined. It has listeners that are listening on, the services that we just defined to those target groups as well. It has SSL certificates that have been defined for the domain and attached to this load balancer as well. What we also have here would be a dashboard, which essentially defines the target requests for monitoring, and ALB requests, our response time, and then service load, where we see how many tasks are currently running. Currently, we have 2 tasks running, so we can monitor that out here. We have, annotations for our scaling and scale out thresholds for our CPU, and we have our target response time as well that we can monitor. Then we also have a couple of alarms. We have a 5xx alarm that I just defined, and then the HTTP response time alarm that we also have defined. These two are auto-scaling alarms. These are what triggers the auto-scaling action on our ECS tasks. So with those few lines, we have all of these resources created, connected together, and we have a web service.
Nice. Does that bring us to the end of the wonderful demo?
That brings us to the end of our wonderful demo.
Nice, nice. Yeah. So less than 150 lines of code. If you told me that like 4 years ago, I would have been shaking the screen like, you're lying. That's not possible, but it is possible. Thank you so much for walking through all of that. In terms of a recap, you kind of gave that one, but were there any points on that you would like to throw back to Mathijs or Kelvin?
I guess I think the bottom line is that this makes it much more accessible for regular application developers to develop infrastructure.
Yep,
it does.
We kind of talk about it as the infrastructure as code for the everyday developer, because it has a clear interface. It's approachable. It's not daunting. Like, if you see a CloudFormation stack, you're like, what the hell is this? But it's kind of approachable. It's code and language that you already write, so it's easy for you. If someone tells you, if you're onboarding and someone shows you, hey, this is our infrastructure code, you might be a little taken aback and also relieved that, oh, this is already like a language that I'm familiar with. I can actually dive into this and change something. Like, you don't have to go call someone to go change an environment variable. You can do that yourself. You don't have to go call someone to change, like we said, an alarm to not alarm on production. You can do that yourself because you know how to write that code.
So question from the development empowerment perspective, throughout your whole stack, end to end, is it all TypeScript based, or do you have other languages in the mix?
It's pretty much all TypeScript. I would say like 99% at least. I think there are a couple times where we need to like dive into HCL, but those are very rare. And we do have that possibility if we need to.
Kind of want to bounce it. I don't want to ask all the questions. Or Sarah, did you have any particular questions before I ask more?
One thing that I think is really exciting and great about the demo that you showed is you're really demonstrating how your team was able to customize the interface like you talked about by creating all of these sort of abstraction layers and sort of like constructs to really empower developers to know that like I'm doing the right thing, you know, like the team has like established sort of the best practices in these libraries. And so I don't have to kind of take that on as an individual developer. And I think, so I just wanted to kind of make a plug for anyone who's watching to just check out those repos that are linked below the video, because I think that's the real strength of this demo is you're really showing how the team has taken like the CDKTF as a tool, but customized it for your team and your, you know, your usage and best practices. But I guess the only question that goes along with that, Matthias, I think you said this earlier, it's sort of an iterative process, but what was sort of the initial lift, you know, to kind of create those constructs to make this workflow so seamless and, you know, so easy to use? How did that work on the team?
I think there was just a decision that going forward HCL wasn't feasible. And we pretty quickly decided to create this shared package where we put our infrastructure and our shared patterns across our services. And I think that decision was a really good one.
Yeah. And to add to that, I think like one of the points was we kind of shifted to like kind of this new way of building out our services with code deployments and all of that. And then we did all of that in HCL for one of our services. And we quickly realized that we don't want to do this for every service because it was a lot of files to bring that together. So we basically realized this is not the right thing for us if we are going to keep building our services the way that we hope to build them in the future. So the CDKTF came at the right time. That's why we are early adopters, because when we found it, we're like, great. Like this kind of like changes everything. Because, you know, we're obviously like looking at options as Pulumi, like, but, you know, this was kind of in line with what we're already doing with Terraform, HCL. So.
And maybe also to add that we still have full control. Like there are other services that will make it very easy to deploy Docker images, but don't give you like full control of the resources that then get created. If we needed to, we could just expand this demo file with additional resources, even without going to our shared library. So the developer, we make it very easy for the developer to create these services, but we also give them the full control to make modifications.
Wow. Yeah, that still astounds me that as a developer, I mean, someone comes to you, says, I have a new service I need to stand up. And y'all are literally able to say, all right, here's an example, go make it, deploy it, and you're done. Like that's basically not a hallucination. That yeah. Happens.
So we actually have a template. I think it's currently open source. We have a template repository or code base that we use to spin up new services now. It's pretty much all in there. Like what the developer usually needs to do is just kind of rename stuff, really. Just based off of that template, just rename a few things. You get all the CI/CD, all the pipelines, and basically the base of your application. So all you do is just add to it for that specific service.
Nice. So going on with that, y'all touched on it a little bit at the beginning, but we obviously have the repos listed below the video. If an organization or team outside of Mozilla wanted to come in and use these for their own purposes, how would they go about doing that?
So in our open source Terraform modules repository, if you look at the structure in there, and I encourage people to go check out the repo, in our source directory, we've divided that into a base and then a pocket. Everything within pocket usually has something specific to pocket in there. So we define like constructs that are specific to pocket. Everything within the base are also things that like we've kind of like put together from CDKTF. So like there's something called like an application ECS cluster. that just has a few configurations to create an entire ECS cluster with the service. So it's still very like modular and useful to create things that will otherwise take you a long time. So if anyone else outside wanted to use this, they could start from the base constructs that we have, and then also build themselves something like the Pocket ALB application resource that we just used here as well. And if you really did want to use what Pocket was using, if you look at a code base, you would see that things that are making it Pocket specific, like, the sensible defaults that we have in there, maybe a VPC configuration or something, you could set it up the same way if you kind of just follow the code path of like what we've done to make that possible.
And we've also listed a couple of open source repositories at Pocket that leverage this shared library to build services. One of them is a recommendation service. We have another, just a simple REST API. So a couple examples to get started with that.
Nice. So I do have another question. It's kind of a possibly a little more abstract. So one of the things, so obviously I love both HCL and I mean, I use TypeScript, that's and JavaScript. I use those for a very, very long time. One of the things I'm always asked and interested in is the moving to a programming language for more power, right? You want more power to be able to do what it is that you want to do. And obviously familiarity is part of that. But the counter argument I'll get sometimes is, well, how often are you using those powerful pieces of your programming language? Like how often are you creating complex control flows that you couldn't do in HCL? And that's the question I'd like to ask to y'all. Like you touched on it briefly during the alarms part, that here is a very easy way to do conditionals in a language you're familiar with, but whatever other aspects of TypeScript do you guys take advantage of that you didn't see possible in HCL?
I guess type checking is one. Composition is another. So like making subclasses of an existing resource. And I'm not really familiar with like how that would work in HCL, but I guess that's also the point, like the familiarity that you mentioned. So I'm not really sure like how, if and how you would do that in HCL. But TypeScript is a pretty powerful language, like many other modern programming languages, and it we really use it in a lot of places to make our infrastructure more readable and extensible.
Also, with kind of using TypeScript, the IDE support and the community support is also like great for that language by itself. So, and then also with HCL, even if you broke things into different files, at the end, it's all kind of like mushed together when you're going to run your apply. So like there isn't a real structure in the sense of it, like when you write out your different files. But like if you're using a coding language, obviously like there's like Mathijs mentioned, there's like a hierarchy of like how things are happening. And then you can also like get into the meat of like what is doing what. With HCL, if you don't have any kind of like IDE plugin or whatever that is, helps you kind of like just click and dig into web resource and where it's coming from, it's kind of really hard to like move around and like find your way around that. It's not like that easy entry to like a new developer that's been onboarded. It's like, hey, go install this plugin and maybe you might have some syntax highlighting, but you might not have code completion, but like, it's fine. But in TypeScript, there's also that support from like multiple IDEs. So once you jump in there, chances are a developer is already going to have an IDE that supports that and be able to move around pretty easily.
Good answer. Mature ecosystem and tooling around all of it. I do want to plug our VS Code Terraform plugin we do have for HCL. And I also want to say that I do love HCL. So even though we're talking about these other things, HCL is awesome. It is awesome. But obviously, if you wanted to satisfy the use cases and stick in something you're familiar with, especially in teams, and when you're entire, the rest of your stack is TypeScript, this obviously makes perfect sense. Sarah, do you have any other questions, comments around the product aspect, or really just curiosities in general?
No, I think I'm just so appreciative of the team sharing this demo with us because, I think as most people know, the CDK for Terraform is a fairly new tool. So we don't have a ton of like production sort of ready examples. So it's just really great to see in this demo how like you're pulling in all of the resources, not just deploying an application, but like setting up your PagerDuty alarms, like setting up your load balancer, just kind of seeing the full production ready package. So Yeah, no, just want to thank the team for doing this and making it open source so that other people can check it out and, have learn from your experience. So more just a thank you than a question.
Yeah, it is nice seeing a production workflow, something that can give ideas to people trying to set up these workflows for themselves, as opposed to, simpler, more siloed examples that are useful and have their place, but don't necessarily spark the imagination as much. So I do appreciate it. Well,
I feel we should thank CDKTF for being open source and HashiCorp. So thanks so much for that.
Yep. And it came at just the right time. So thank you for that.
Nice.
Maybe the one thing that I might want to mention, maybe a sort of like a question for myself and for folks, migrating like an existing repository to this. It's something that we are also like still looking into, like with the deployment of the converter tool, like that might make these things a little easier, but it's also something that we are kind of looking into. So if you're thinking of converting an existing repository, maybe keep that in mind that, it's not as straightforward as starting a new repository with CDKTF.
Yeah, that's a great call out. And we've definitely heard that from various folks or sort of early pilot users of, starting a new service is working well, but what about all of our existing projects that we want to move over? So I think that's something the team is definitely thinking about. We do have steps towards this, like with the convert command, where you can take existing HCL, but nothing at the level you're talking about where it's just like, I have a running project and I want to move it over. So it's definitely something that looking forward to talking with you all more about as we figure out the right workflow for that.
Anything else before we wrap things up here? No? All right. Well, for everyone interested in doing more with the CDK for Terraform and learning from the folks at Pago, we have a ton of resources listed below the video. As I've said before in previous office hours, if you're interested in getting into the CDK for Terraform, check out our Learn platform. We have a ton of guides around it. And if you have any issues or feedback, go to our GitHub repository and open up an issue. I do promise that those are looked at. We are reading and we're grateful for all of the feedback that you give. However, as you've noticed, for more advanced users looking to take the next step and get some good best practices and architectures, please take a look at the various repositories listed below from Pocket. They are a treasure trove of best practices, architecture patterns, and innovative usages of the CDK. I can give you a lot of ideas to smooth out any wrinkles you might have in your workflows. And also give Pocket a try. Give it a try. A messy chaos of bookmarks. I mean, come on, I got a whole ton of those I don't even look at. So having something that can recommend things to you and obviously save the interesting things that you've run across is something humongous. And it'll also support a great company in Mozilla and the wonderful Pocket team. And then the last thing is that we do have another upcoming stream with the Mozilla team where they're going to give a much more involved coding session for those of you interested in diving even deeper. So look out for that on October 27th. And one more thing I'll plug is we do have Hashi Talks Japan today at 6 p.m. Pacific time. So if that is something that interests you, look out for that on our stream. And any last words from Mathijs, Sarah, or Kelvin?
No, thank you for having us.
Yeah, go open source.
Nice. All right. Thank you so much, all of you. The demo and discussion was so useful and insightful. And thank you to everyone that stopped by to the stream. And thank you to all the people who are viewing this later. Until next time.
Yeah, thank you.
Bye.
All right.